Here at Station 6, we're talking about exponents and radicals. This is what you just took a test over for unit number 5, so it should be the most fresh in your mind. Here are some rules. If you forget what to do, write it out. For example, if a problem says x to the 7th times x to the 2nd, and you can't remember the rule, write 6 x's, 1, 2, 3, 4, 5, 6, 7 x's, 2 more x's, and count them out, and you'll remember that that actually means x to the 9th power, which will remind you that the rule is add. 7 plus 2 is 9. Okay, the next thing is remember that anything to the 0 power is 1. Next, we talked about negative exponents. We said no unhappy apartment dwellers. If you don't like living on the top and that makes you negative, move to the bottom and get positive. If you don't like living on the first floor, move to the second floor and become happy. Move the exponents if they're negative. The next thing we talked about was multiplying like bases. If I multiply two things with a similar same base, I can add their exponents. And I gave you an example of that just a moment ago. If I'm dividing two things, like x to the 7th over x squared, I am going to write it all out and cross out common terms, which in this case would give me x to the 5th power. What I did there was subtract exponents. The last rule we talked about was raising a power to another power. For example, x squared all to the 3rd power. And that would be like writing out 3 groups of x squared. So x squared, and x squared would make x to the 6th. And that reminds us that the rule of raising a power to a power means I'm going to multiply the exponents. Also, I included here that PEMDAS still applies because sometimes these problems can get complicated and you'll be given more than one piece, so you just need to follow PEMDAS. Let's look at this first example. B to the 3rd power times b to the negative 2 times a to the 0 times c to the negative 4. The first thing I notice is that I have parentheses, but there isn't anything that can be done within the parentheses. So the next thing I see is multiplying. When I multiply things of like bases, I add their exponents. So b, 3 plus negative 2 would make b to the 1st, a to the 0, and c to the negative 4. Now I see 0 exponents. So anything to the 0 power is 1, which means I can get rid of this term completely because that's like saying b times 1 times c to the negative 4th, and multiplying by 1 does not change anything. I'm going to leave the b alone because he's happy in his apartment, and c to the negative 4th is unhappy, so I'm going to move him down and make the exponent positive. And that's the solution to this problem. Go ahead and look at this one. On your test, this is the type that most of you struggled with. Let's start with what are my 3 different bases? I see 4, x, and y. The 4, there's more of on the top because there's 2 of them. So I'm going to leave it there and I'm going to subtract 2 minus 1 would make 1. Now I'm looking at the x's and there are more on the bottom, so I'm going to leave the x on the bottom. And 5 minus 2 is 3. Last, I see y. There are more on the top, so that's where I'm going to leave it. And 7 minus 1 is 6. And now I'm done. I've simplified as much as possible. I have 3 different bases, and that's all I can do there. The second part of this station is about radicals. I drew that heart to remind you that it's as easy as dating. Pairs go out. And when I say out, I mean outside of the radical. Singles stay in. And remember, to do this, we would make a factoring tree using prime factorization. If there was a term on the outside, we left it and kept it outside of our factoring. If I think about the number 108, I think, gosh, I don't know anything that goes into 108, but it's even, so that tells me 2 does. And if I use my calculator, I can say 2 and 54. Well, I'm not sure what goes into 54 either, so I'm just going to divide by 2 again because it's even, and that's 2 and 27. Remember, I marked out the things that I had a branch coming from so I won't forget them later. And then I have 27, which I know is 3 times 9, and 9 I know is 3 times 3, so I can kind of work from there to create my tree. Then I want to circle pairs. Remember, this one isn't a part of it, and maybe I shouldn't even write it there. How about I'll write it to the side so I know it's a part of the answer and not a part of my factor tree. Now that I've circled these pairs, I can write them on the outside, so 2 and 3. And then on the inside of the radical, I have this one single 3 left over. I haven't done anything with my variables yet, so I'm going to need to figure out the pairs involved with that as well. I have x to the third and y to the 8th. So I'm just going to go ahead and write it out. Your teacher may have taught you a simpler version on this. If you're my students in certain classes, I may have shown you, but for now we're just going to stick with this. I'm just going to circle the pairs, and I have one group of x's and 1, 2, 3, 4 groups of y's, so that's y to the 4th. And again, I have a single x that stays on the inside. The last step in simplifying this is to multiply the stuff that's remaining. So I have negative 2 times 2, which is negative 4, negative 4 times 3, which is negative 12, xy to the 4th power, square root of 3x. It looks like a complicated answer. I wanted you to see one that might be a little bit more difficult, but the point of it is the pairs go on the outside, the singles stay in, and at the very end you multiply it down. Let's do one more like that. This one also has 1 on the outside, 3/10, so I'm going to leave it, and I'm going to break down that 50x to the 6th power. I know that's tiny for you to see. I'm going to break out the 50 and the 6x, and for 50 I'm going to say 25 times 2. For 25 I'm going to do 5 times 5, and I've got that into prime numbers, so I can pick my pair and my single. Go ahead and draw my radical symbol, or square root as some of you like to call it. The 5 is going to go on the outside because it's a pair. The 2 is going to stay on the inside because it's a single. And now I can break down that x to the 6th power by writing 6 x's. Can circle my pairs. As you can see, there are no leftovers or singles to stay in, but there are 1, 2, 3 groups of x. So I have x to the 3rd power. And then I just need to simplify. Right here I'm going to have to use my calculator. What is 3/10 times 5? 3 over 2, x to the 3rd power. I noticed that some of you were very hesitant about using your calculator on the exam, and as a result, you missed some of these. Please don't be too prideful to get the right answer. That's it for Station 6.